product enhancements and some product evolution as well. Before we get started, I just want to introduce everybody from a galvanic perspective who's going to be in the room with us today. So first of all, we have Eric Budlong, who is kind enough to actually put this whole presentation together for us and make sure that it looks as good as it does and gives you the information that you need to be able to successfully go out and promote this product out in the field. We also have Steve Stadolski, who is the platform manager for the Monitek product line in the room as well. And he's going to be doing a large portion of the presentation discussing the Monitek line itself, the enhancements that we've made, and also some of the applications and success stories that we've had previously as well. Lastly, we have Parisha Akshi in the room with us. She is the newest member of the galvanic team. She comes to us with a long history in the analytical world and with specific background in sulfur recovery and in instrumentation. And she's been with us since January 7th, I believe, at this point in time. And she's going to be in a senior platform manager role with the organization. So that's the team that we have here today that's going to be talking to you specifically about the Monitek line. And without further ado, let's get right into the presentation and move forward. By the way that we're going to go through this is it's going to take an hour or less. And in terms of questions, if you can be asking your questions through the chat line, Eric's going to be reading out those questions to Steve so that we make sure that we're not interrupting on a continuous basis, but we do want to have questions asked as you're going along. So please don't hesitate to ask any questions. Put those online, and then Eric will read them out at appropriate stoppages during the presentation. Okay? So without further ado, what we're going to do today is we're going to give you an introduction to the Monitek. We're going to talk about key applications. We're going to talk about the design and user interface, how it works, and the competitive advantages. And this is me. So I have a VP Sales and Marketing, and many of you I've had the pleasure of meeting most of you who are online. If not, I look forward to meeting you in the near future. What we're going to do is, again, talk just about the Monitek specifically and introduce it, and then talk about some features and benefits, and then design and user interface. I'm going to talk about it from a very high-level point of view, and then let Steve get into the details or the nitty-gritty of how this actually works. So, the introduction. Process analyzer measuring physical properties in liquid. There's really two major things that we talk about here. One of which is turbidity, or total suspended solids, and color using the optical light scattering technology. Again, this is a light-based measurement that we're using, and Steve will get into actually how that works. So the features, really key things to be aware of is the powerful cleaning jets. They're protects the opticals from fouling. Imagine if you are using a light source and you foul and you actually cover the light source, it doesn't actually work very well anymore to be able to measure. So we have very good, powerful cleaning jets to make sure you're getting online continuous measurement, even in some of the toughest applications. We have application-specific sensors. Really, we can design and engineer things to be specific to the application. So there's a lot of off-the-shelf products. This is the way it goes into the installation, and you have to redo your installation to work around the sensor. Where we have the capability to engineer to suit based on your installation or the customer's installation requirements. 1 second response time. Again, this makes it easy to be able to do online control and monitoring in the application. Multi-parameter option. You can combine multiple analytes such as color and turbidity into a single sensor as well, which gives you the fast return on investment. So you're not looking at two cells, you're looking at a single cell to do multiple measurements. And the last one is the analyzer has the ability to have two sensors with a single analyzer. So even if you're buying one analyzer and the sensors are close to each other, you can actually reduce your total capital investment by having a single analyzer and two sensors there. Here's some key applications that we've had some very good success with in the past, and Steve will talk more about this as well. So from a turbidity point of view, we take a look on the petrochemical industry, catalyst protection, making sure that you're not getting any particulate and or carryover of things that you don't want to come into that actual catalyst. Chlor-Alkali, you can look at chlor-alkali brine purity. Food and beverage, we look at beer wort clarity. Again, you can look at the actual suspended solids that are in there and make sure that nothing's coming through and going to be damaging or affecting your overall process. Total suspended solids, refinery, filter breakthrough, protection, making sure that the filter's working properly and not allowing things to come through that shouldn't be. And wastewater, again, clarifier polymer dosing control to make sure you're getting exactly what you need. From a color point of view, one of the applications that has had very good success for us is the NGL Saybolt color. So we can actually measure color online continuously in those applications to make sure you're running your process properly. Food and beverage, edible oils product quality, and on the industrial side of things, ion exchange resin breakthrough. So here's the design. Here's the messenger transmitter. We have fiberglass, stainless steel, or explosion proof. And this is one of the things that's really an advantage for us. There's a number of different styles of analyzers that we can use. So we're literally from a NEMA, a regular application, normal general purpose application, all the way up to a class 1 Div 2 analyzer that can be installed without a purge and be able to go right into your installation. The user interface. So the way that this was designed was to make it as easy as possible for the customer to be able to walk up to the analyzer and be able to program, monitor, do whatever they need to do with the analyzer. So it's a complete touch screen. And you can go through the entire user interface by walking up to it and be able to push the buttons and make it work without having to have a separate keypad or to be having to have a handheld unit or anything else to be able to do this. You can walk up and do full programming and be able to get more information out of the analyzer as well in terms of graphs and other pieces of information. So again, this is just a high-level overview in terms of the analyzer, the system, how it works, and what some of the key benefits and features are. At this point, I'm going to turn it over to Steve, who's going to get into much more detail in terms of what's new, the operation, sensors, maintenance, and installation. So Steve, over to you.
Thanks again. So I'm Steve. I've met a bunch of you guys in the past working here. I've been here about 19 years with the Monitek line. So we'll go through what's new, the theory operations, what our sensors are, some of our maintenance, and some installation examples, and some of our installation wins, we'll call it. So what's new? So right now we successfully made some new arms, and we're getting certification for CSA for Div 1 and 2 for the sensor arms. And so that's for the sensor. And for the transmitter now, it will meet CSA Class 1 Div 2 without a purge like it previously did. So no more having to plumb up for a purge to put either a Z purge on the unit. It will meet as it sits without a purge in a stainless steel box. So of course, when we talk turbidity, it's a 2-channel measurement. We do a ratio measurement where we look at a direct beam, which gives the intensity of light at, if there's 0 ppm in it or 0 turbidity in it, like clear water, like a clear glass of water. And then we have either a 12-degree or a 90-degree side scatter method. So what happens is, if the particulates get in the way of this focus beam, it sends the beam out of focus. So we essentially, on the direct beam, which is the reference channel, which is 180 degrees from the lamp, it absorbs some of the energy. So that energy drops, but the 12-degree or the 90-degree pick up on this lamp out of focus because it gets bigger and it's allowed to pass through the apertures, and the signal increases. So it's a ratio measurement. And the reason we do this is because if it was a single channel measurement, like a most standard infrared single channel absorption measurements, they cannot account for lamp aging or any coatings on the windows, or sometimes some color changes. With this device, the way that we do it, if you get slight window coating or lamp aging, both channels drop the same amount, but the ratio effect still takes place when the particulates of interest are in the path length of the light source. So that's, you know, the quick and easy on how the unit works. And of course, from those ratio measurements, what we have is the factors that we put into the calibration table, and those correspond to the ppm value or NTU value, or percent solids level that we calibrate the unit to, and it's a lookup curve, and it outputs the data through the transmitter and out of 4 to 20 analog output. So the first type, the majority of them that we do is a 12-degree forward scatter measurement. And what that's used for, that's a great device for if you have a customer that says, hey, you know, we've got this pipe that's flowing X sample out of a filter or a centrifuge or whatever, and we do a dry solids on it. So they do a weight to volume measurement, so a ppm or milligrams per liter. This fits in really well with that 12 degrees. And it correlates very well to dry weight solids, to if it's higher range, to even like an MHOF cone, where they look at how much settles out in a tapered cone, and they can correspond what the ppm value or milligrams per liter on it. Works really well for that. Very sensitive to large particles. And when we say large particles, we mean, imagine if you go out in the parking lot and you pick up some sand, just regular sand, and put it in water and mix it up, and what that looks like. It's something that you can physically see with your eye. So I would say down to about the 2 to 3 micron particle size. And that's why we calibrate these, again, using the weight to volume method, using a standard of diatomaceous earth that we have here, which is just an ultra fine, you know, half a micron to about 2 micron particle size of a silica particulate. And it stays suspended really well in the sample or in your standard, and it makes an amazing media to calibrate the units quite easily. Well, now if we have a customer that says, well, we want to look at a haze phenomenon that happens. So imagine if you took, the best way to describe it is if you took a clean glass of water and you took a little drop of whole milk and put it in it. You know how you get that cloudiness, but you really can't see any particulates because it's so ultra fine? That would be what when we consider using the 90 degrees, because that is extremely sensitive to haze, which is the phenomenon of almost no particles at all, just a haze measurement. So that's when we would go with a 90 degrees. And a 90 degrees measurement, what kicks it off for me when I look at an application data sheet is if they say we want to do a measurement and the units of measurement are NTUs or FTUs. That's always 90 degrees. So if that's the case, we wouldn't sell them a 12-degree system and calibrate it that way. We would do a 90-degree, which is what's also referred to in the world as a nephelometer. And you know, all these companies are going to have the little handheld Hawk unit or a device like that, and that is the geometry of that is 90 degrees. You know, it probably doesn't have a halogen lamp source like we do in our process unit. It'll probably have an infrared diode, but absolutely you can be assured that the optics are in an arrangement of 90 degrees from the lamp, just like we show in that little diagram with the yellow with the light going through, and at 90 degrees. So if, you know, that would be the unit that we would offer for that application. So here's a couple examples of different flow cells that we would use. So if we talk food and beverage or pharma, I think everybody's seen these at one point in time of dealing with instrumentation. That top left upper hand one, that's a typical one that would be used in a brewery or in food processing, especially here in North America. That's what we call a triclover. I'm sorry, that's called a Tugendhaken fitting. The bottom one is very similar. That's a triclover. Actually, the triclover is more what we see in North America. That's what we'd be accustomed to in food and pharma and also breweries, where in Europe or overseas in Asia, it would be the top one, which is the Tugendhaken fitting. There's an example of an explosion-proof, either a turbidimeter or color sensor on the upper right-hand corner. And the lower right-hand corner shows us what we call the FS, the monitor forward and side scatter device. So that one will actually do both. It'll give you 90 degrees and 12 degrees. And that's a pretty good picture, as you can see, from 180 degrees from the arms, that is the lamp and the forward scatter detector, or the 12-degree detector, and then obviously at 90 degrees from the light source is your 90-degree or NTU detector. So here's theory of operation, something very simple that we do, which is we have a near-infrared device, which we call the Monitek A. And this is just a gap probe, meaning we have two windows, a light source on one side that is anywhere from about 800 nanometers up to about 1400 nanometers infrared. And this simply measures solids and particulates in that flowing path. And we correlate absorbance units to the ppm range. And this would be used where if a customer is saying, hey, we want to do anything from 300, 400, 500 ppm and up. Well, when we get to that level, our forward scatter, our dual channel system, because of the optics and the geometry and the apertures, we really reduce the lamp signal. But also what happens is at that range, the sample itself absorbs too much. So a forward scatter ratio measurement doesn't really work. It's not a great success story if we go that route. So that's when we'll take a look at it and say, all right, we'll do an infrared, the Monitek A, the simple single channel, and we can easily meet those ranges, and even higher than 1% we've done with extended windows, because it's all about gauging the optical path length versus the amount of signal we have available, and ultimately what the range of solids will be. So that's something that I help the sales guys out with here, and we determine, how we're going to build this and construct it, and then obviously get a quote out for that, and it's all done in house. Oh, why don't I just go back real quick? I just wanted to see what that last one was about. Okay, so yep, we covered that. And here is, so again, the pipe mounted one looks just like a forward scatter or a two-channel color sensor. It's two arms, 180 degrees apart from each other. And then we also have some of these probes. These are submersible probes, which work in the same way, infrared. They're just a gap probe. And the one that's called the CSK, that's for very high solids. We can go anywhere from, call it 3000 ppm, really accurately, to about 5% solids loading. In that, these are typically used, the CSK and CSS, the CSS, let's go over, that's the lower TSS. That will be anywhere from about, that'll measure relatively accurate from 50, 60 parts per million solids up to about 3000 ppm, so about 0.3%. And these are typically used in clarifier applications where you have a facility in their wastewater end where they have either a clarifier or a thickener, or a settling tank, and they want to know what the volume is of solids coming in, and possibly they're also adding polymer, polyacrylamide polymer, to settle out these particulates and pump off the sludge off the bottom and reuse this water back somewhere in the plant. So what we would typically do is put the CSK probe in the center well of a clarifier where it measures the loading coming in, and that will actually throttle the polymer pump to use just exactly what it needs to make clear water going over the weirs on the clarifier, or the outer well of the clarifier. And that's where we monitor that. Sometimes the customer wants to know exactly that, we visually, obviously, we can see that the clarifier is working well, but if no one's there, well, then they can add to it. They can put the CSS probe, which is the more sensitive one, to see the clarity of the clarifier after the polymer and the settling has taken effect. So theory of operation, this is the color sensor. Again, it's a two-channel system. We measure, any flavor or chemical and color that you guys come across. And we typically will do this from 400, and the measurement channel will be anywhere from 400 to about 700 nanometers. And this will be a 2-channel system. So let's just talk on easy one that everybody has probably experienced at some point in their life, which is platinum cobalt color units, or APHA, or Hazen color units. That's all the same. That is all the time done between 450 nanometers or 400 up to about 460 nanometers. That's your measurement channel. And this looks at the color, what I call the wheat color of a liquid. So imagine if you take kerosene. Kerosene, for most parts, is water white. It looks completely clear. And then imagine if you had a glass of gasoline. It looks more yellow in color. And of course, diesel goes darker than that, and so forth. So that is a very typical measurement, and that is where we would do that. So 450 nanometers is the measure on that, and 850 in the infrared is the reference. So again, like the turbidity, where we reference the lamp energy and also lamp coating, we do the same in color. Because if we only did a single channel measurement at 450, of course it'll work. But what happens when you have particulates or lamp aging or contamination that starts to get on the windows? That will be additive, because at 450 it will see this, but in the infrared it's blind to color, but it will see this. So what we do is we take and we subtract the interference out of it, and we give the color of interest corrected for lamp aging and particulates or window coating. So these are just some examples of our color sensors we've done. So obviously the standard typical one is up in the upper left-hand corner. That's our Monitek AD dual channel color general purpose area. The one just below it is an explosion proof device, either class 1 Div 1 or Div 2. We've done some custom-made Teflon ones for some highly acidic samples. So that's actually a carbon-filled Teflon device, flow cell. And here's one that we're really happy with on below that, which we call the Monitek AD high pressure. That device is rated class 1, Div 1 and 2, and will work up to about 3,000 PSI. So this is one that we've been pushing an awful lot with for the pipeline NGL Saybolt color, from 30 units, which is 0, to 15, which will look like an iced tea. So in between that range, that's a very important measurement that we do. And that is a relatively new device that we've been pushing now for about 3 years. So, and keep making improvements on and diving into that market with. Another example of a custom sensor. This was one that we did for a client in China, in Taiwan. And we measure copper sulfate with this. So we measure high range copper ion for the copper foil manufacturing. So it's extremely acidic, about 30 to 40% acid with copper dissolved in it. So as you can imagine, it's highly corrosive. Stainless steel would not succeed, and it would be cost prohibitive if we made it out of a metal that would work in it. So we looked at it, and the best choice for that application is a carbon-filled Teflon, and then the arms are all coated with a black Teflon coating that we have put on, and so the atmosphere will not corrode it. You know, they've had success. They've been installed now. I have some of these that are going on 10 years old, and they look just as new as the day they arrived. No corrosion. So that was a real improvement. So again, this is a little bit that Ian had talked about, so we'll go a little bit deeper. So when we say multi-stream, that means obviously there's a 2-part unit. We have a controller that mounts on the wall, which we call the messenger PC or touch panel controller. And we can mount up to 4 sensors if they're single channel, because the limitation that we have with the transmitter is we have 4 inputs, meaning 4 photodiode inputs and 4 controllable lamps. So imagine most of these that we're talking about today are 2-channel measurements, right? They have a reference and a measure, be it color or turbidity. So if we look at that, we know that each sensor has 2 sensors. Each sensor has 2 photo detectors in it. So it takes up 2 channels. So that means we would be able to do up to 2 color sensors on one transmitter, or 2 channel turbidities on one, or up to 4 of the single channel infrareds on one, or a combination of that, just as long as we have enough channels. So that's something to be aware of, that we're pretty flexible, and I'll help you guys with that. Sample temperature, obviously, 0 to 140 C is where we're at right now for our certification. The important one being that 140 C, and that comes into play just based on pressure holding. They'll work at higher than that temperature, but you start running into elastomer issues that seal the windows, and under pressure that can be an issue. So again, sample pressure right now, we can do that high pressure one, although it will easily work up to 3,000 psi, like I mentioned. If it goes into a Div 1 or Div 2 area, we are only certified right at the moment to the 1400 psi, which works out well because this application is again in the NGL method for Saybolt color that we do, and those are typically between 800 and 1100. So we have a 300 psi buffer, so that worked out really well. Size of cable, this is just the actual cable going in and out of the transmitter between the two. I'm sorry, I read that wrong. The size of the sensors, we do anything from 1/2 inch NPT up to 4-inch ANSI, and everything in between. And one thing to be aware of is if it's a flange system, or if it's going to be an NPT mounted one. Imagine if you have a customer that has an existing older device or competitive device, and their dimensions are X between the 2 NPT fittings, or between the ANSI flanges, that our system might not fit, right, our standard one. But if you can give me the dimensions that we have, we do a quick drawing, we modify it, and we quote it that way. It doesn't really add much to the price, but I'll make a system fit for the actual application. So your customer will not have to do any pipe fitting except for install this. It will fit right in the space that they have. And we offer up to 100 meters of cabling between the transmitter and the sensor. So the standard is 5 meters of cord, but a typical one that we do is between the 10 and 20 meter length. So, 33 to 66 feet, that's kind of the sweet spot for us for those devices between the connections. Again, connections, we offer the European DIN flanges, ANSI flanges, what we're all familiar with here in North America, NPT, the TH, the straight thread for European, and the tri-clamp or Tugendhagen sanitary fittings for food and beverage. The elastomers that we use to seal the windows are anything that's available. We have a size in there that we have made. A typical seal it's a 2 millimeter by 20 millimeter, so they're off the shelf, and we offer anything from Viton all the way up to Calorized, and everything in between, EPDM, some Teflons as required. And our windows are standard. It's always a man-made grown sapphire crystal window. So it's just like your expensive Swiss watch. It's not going to scratch. I have customers where they say, "Oh, Steve, something happened. We got some metals coating on it. We plumbed this into a new facility. It's all black iron, and the slag came through, and now we've got this, nasty rusty coating on it. So obviously it won't work." So I tell them, well, does it wipe off? He's like, "Well, no, we took it out. It doesn't." Go right to a scouring pad. Take a Scotch-Brite pad to it. You won't scratch it. Clean it right up in about 2 seconds. And rinse it with water and reassemble it. So that's why we go that route. It's very, very heavy duty. And again, the bodies, all the wetted materials, as long as it's a material that my machine shop can purchase, an alloy that's on the market, we can machine it and make it out of that. So we're very flexible. So obviously our standard is 316 stainless steel. A good second place would be Hastelloy C. We do a fair amount of those every year. To real exotic stuff, some of your nickel stuff, the Monels, and then obviously Teflon or Teflon coated stainless steel. So again, installation will be pipe mounted, either flange mounted or NPT or a submersible probe. This just shows what we talk about when Ian had said the powerful cleaning jets. What we use for cleaning jets for the submersible and our pipe mounted devices is just high pressure air. And we can control that cleaning event in time and how often through the software. And we include now, that's something else new, is we never used to include the little ASCO or Red Hat valve. We include that now. It's mounted to the messenger if the customer buys cleaning jets. We provide the required amount of tubing between it, so everything is easy and turnkey. And typically, most samples that we see for turbidity are going to be in the range of either at atmospheric, if they're submersible or whatever the water weight above it is, not too much, to about 60 to 70 psi. So obviously we want to have pressure in the neighborhood of 30 to 40 psi higher than the pressure for that to work in a pressurized system or in a plate mounted one. This just shows how easy it is for the maintenance. It's typically 6 screws to take the retaining plate off, to get to the O-rings and get to the window. All field replaceable, not a problem. But that being said, I like to always, when I'm at a sales visit, say, listen, there is going to be some maintenance on this device, so have a way where you can block this unit out of the process flow, or you can divert it around it so you don't have to shut down, and you can drain the cell, have it shut off from the process pressure and do your maintenance. So we say yearly on the O-rings, especially if they're Viton. Calres can go a lot longer. Windows and lamp replacement will also. Windows actually is lifetime because they're sapphire, but window seals yearly if they're Viton or EPDM. And lamp replacement. There's a halogen lamp source that you can see over in the in the right-hand corner, and that is also field replaceable. And you can shut the lamp down using the messenger, let it cool down for a minute or two, and go ahead and remove it and replace it. And we like to do this yearly. If the lamp does burn out, the transmitter is smart and it gives you an alert that's programmed that says optics fault and lamp fault. And also we can tie to that something that would not be common on a 4 to 20. So we can either send 21 milliamps out the line or 3 milliamps, below 4, and that will trigger an alarm in the customer system that they can program. Here's just a couple of pictures of examples. This is an actual LACT skid that I believe is in Wyoming that was just started up last couple months ago. That is a high pressure NGL system. So that is very typical of how it's installed. So sample comes in and out at line pressure. And this one I believe was right up there. That was around 1200 psi. As you can see, the messenger is sitting in the right-hand corner on that panel. That's a NEMA 7, Class 1 Div 1. Now this area, believe it or not, is Class 1 Div 2. But as you can see, it's remote. It's somewhere out in the prairies. It's hard for them to waste instrument air here. So we make it really maintenance free, and we just upgraded them to a Div 1 transmitter, which is overkill. But the beauty of it is no one had to run any airlines out there and worry about the purge failing. So it just sits out there and runs. These are a couple other ones for our turbidity on a panel where we have a pressure regulator to control flow, all the way up to one of our older units, which is the Model 210, and that looks like that's on
somewhere in Taiwan.
I don't know where that one is. A couple examples of how they're mounted. This is an example that I kind of chuckled at yesterday. I said this is an example of how you don't want to mount our optical devices. So if you see that sensor that's mounted on that pipe, right off the bat I see an issue where they have a little sight glass that's underneath it that will let ambient light come up. And if this was a scattered 12 degree or 90 degree analyzer, that extra light coming in there, bouncing around and scattering, if the sun gets it just right, will actually create noisy samples results or elevated results that shouldn't be there, because that light, when these are mounted that way, 90% of the time it has a way at a certain time of the day where it can get to that aperture of either the 90 degree or 12 degree detector. And when you're running clean all day, and then all of a sudden you see a big spike and they say, you know, this isn't real, this can't be happening. Well, that's why. So obviously we want to have these in an area where you're at least, I'll call it 3 to 4 pipe diameters distance away from these what I call, sight glasses that the technicians, just that access port where they can actually see what's going on in the sample. So a couple more examples. That looks like a lab mounted one for, I don't know, some custom skid that they were working on, to a long path length color sensor. You can see this one where it's actually like a Z shape, how it comes in and out, opposed from each other. That was for a very low color, and that's how we get sensitivity, is we increase the amount of sample we look at, right? Because just Beer's law. So if the color intensity is constant, but we can't detect it, what can we do? We can concentrate that color artificially by increasing the optical path length between the sensor and detector. A couple more installations. This looks like a unit that probably went somewhere quite cold or hot, maybe in the Middle East or northern Canada. So they put it in, and they put the controller in another heated enclosure or cooled enclosure. And this is one that is nice that I like. This is something common we do, where if a customer wants to have access to putting a standard in it to do a field check, they mount these valves and they can valve it out, and you see those pots on top. You can pour standard in, drain it into it, lock it into the standard, and do a quick check on that. So Ian?
Thanks, Steve. That was really insightful. There's a lot of, as you can see, there's a lot of really interesting and good applications that you guys can get involved in. That will be, that really are value added from a galvanic point of view that maybe some of our competitors don't have a lot of experience with, or don't understand necessarily how to make it be, how to implement it in a way that's really going to create that situation where they're really going to get the full benefit out of the measurement at the same time. So certainly with Steve and with our team involved, we're really going to be able to help the customer make sure that they're getting what they require. So that being said, what is our competitive advantage? So why Monitek? Again, materials of construction. So we can do just about anything. The advantage here is, Steve talked about, normally we're stainless steel, but we did the Teflon coat, the Teflon with the carbon impregnated version for a specific application. Because of the way that we operate, we're not off the shelf. We can do things that are maybe a little bit different than other people and do it effectively and efficiently relative to other people, which also means that we have sensor customization, again, meet the application requirements. So it's not just, here's your transmitter, here's your sensor, it's what do you need to do, what are you trying to accomplish, and we can help you make sure you get the measurement you require when you need it, with the accuracy and the response you require at the same time. And amongst that, we also have the multi-parameter that Steve talked to, and the multi-stream. So again, we can look at customized sensors with one analyzer and multiple measurements, and even multiple measurements within a single sensor as well. So it gives a lot of flexibility to the application and to the end user to make sure that we're going to be able to meet and exceed expectations for what the customer requires. So what if they have a dirty sample and fouls the optics? We have the jet cleaning that we discussed. A lot of other manufacturers will actually use a wiper. Well, if you have anything that's a hydrocarbon based, what it's going to do is just smudge it on the window and actually give you poor measurement results in terms of the actual measurement. So we can do things that are going to ensure clarity and ensure accuracy as well. Cooler pressure regulator fails. We can actually handle significantly higher temperatures and pressures than anybody else on the market. So therefore, you limit the amount of damage that you can get involved in, and you protect the wetted parts, but also you can get into applications that maybe other people can't at the same time, such as the NGL that Steve was talking about. That's been a really a great success for us. Air purge fails. Well, we have explosion-proof sensors, and we also have an explosion-proof analyzer as well. So they can be mounted in these areas without having to worry about air purge. And again, when you're looking at remote locations, that is a significant expense, and something they don't want to do is to have air purges. And we can actually eliminate that from the overall scope of supply, thus reducing overall cost and ensuring certainty in the overall measurement. Need to reconfigure method. Again, we can walk up, it's a touchscreen method, and it makes it very easy to configure, operate, and monitor, and make sure that the analyzer is working properly. So, just want to do a quick competitor comparison versus the Monitek versus the Optek transmitter specifically. So in terms of communications, we have an extra relay, and we also have the RS-485 serial and the USB connection that we can make to it. Again, the enclosure, we can go up to different ratings. We're the only one that can do the Class 1 Div 2 rating on this type of transmitter. And our ambient conditions, we can go hotter, and we also have the touch screen as well. So it gives you easier operation and more flexibility in terms of looking at not only a single parameter, but also multi-parameters in the same transmitter at the same time. In terms of the sensors, really the key here is the pressure, temperature, and flexibility of the sensor. So we can go to a higher temperature at 140 degrees C, and you can see by the pressure capabilities, we can go to significantly higher pressures. When you're looking at applications out in the field, regardless of where you are, they want to get online continuous measurement, not doing side stream type measurements. This sensor allows you to actually be online in the process and be able to make those measurements quickly and effectively because of the pressure and temperature that we can go up to. Again, when you're looking at the suspended solids, same type of idea, and with the color as well. So it really gives you the ability to go into unique applications that are truly value add and be able to differentiate ourselves from Optek specifically and the other competitors that are on the market. Just a quick, we also have full on-site service offerings as well. So we have a host of service technicians across North America, and we can do local on-site startup, preventative maintenance, and training at any location. So we can go anywhere in North America to be able to do that. In fact, we can do that anywhere internationally, and we've done that just about anywhere around the world at the same time. We also do factory acceptance tests. So we can do that actually where the customer will come to our facility. We've done even video remote type of FATs and inspections as well. So we have lots of different services to make sure the customer is satisfied before it shows up and after it shows up. Choosing the right TSS analyzer. So if you're looking at the application, there's two different types that we can use. One of which is near infrared, which Steve has gone into a lot of detail about today. And we also have the Monitek ultrasonic. So this is just talking about one of the other products we have in the Monitek line that we haven't really discussed until this moment. So the Monitek CSK is really meant for 0 to 5%, and the ultrasonic is meant from 0 to 1%. The difference is the CSK is light-based, and the ultrasonic is it's sound-based. The difference is if you take a look at the interferences and what you're looking at, the real difference here is you're going to use the ultrasonic in spots potentially where the light is going to fail, because the light obviously can get blocked off and you can run into issues with it being able to measure. The ultrasonic is actually going to be able to push through and be able to move through that and actually get a bounce back reflection of the ultrasonic and still be able to measure even in some more difficult types of applications. Really here the difference is the Monitek ultrasonic is 1% in comparison to up to 5%. It is a single stream unit, Still, you can do a custom flange, or you can actually mount this into a pipe, whereas the Monitek is a fully submersible if you'd like. In terms of the interferences are going to be similar, but really where you're looking at applications, again, the samples where the light source is going to potentially get clouded over or filmed, the ultrasonic is going to work typically in those applications and give you better speed of response and certainty of measurement in those types of applications. In terms of the investment, the Monitek is typically a little bit more cost effective, whereas the ultrasonic is going to be a little bit higher in price. So when we take a look at the Monitek, measurement certainty, and we talk a lot about certainty from a galvanic point of view. Rapid return on investment. Never miss an expected upset. Because we can have the analyzer working and the sensor working in these applications and be able to eliminate fouling, you're going to get good speed of response and actually be able to measure those. You guarantee product quality and compliance. And most importantly, you avoid manual grab sampling. By doing this online continuously, you make sure that you're always measuring and you're always getting the results you need to be able to process, control, and to be able to understand what's actually happening from a measurement point of view. Galvanic helps you protect your assets. Measurement every second. So every second you're getting this in comparison to the grab sample. Make sure that you're online, continuous, regardless of the application. And with this type of sensor and with galvanic specifically, we have 40 years in difficult applications. Again, we are not off the shelf. We can do off the shelf and we have no problem with that. But when you're looking at your difficult applications, when you're looking at difficult installations, really we have the answers to be able to customize and engineer to make sure that the customer is going to get exactly what they want, when they want it, and create the certainty that they require. Also, promote upgrades. You can see here there's some legacy items that we have in our portfolio that because we've been around for a while. So we have the TT6, CT4, and the Monitek Messenger. Basically, this is an opportunity to go, here's an older analyzer. Let's think about upgrading this to the newer one with the touchscreen and with a lot of other capabilities from a communication and classification point of view. So we can use the existing sensors and be able to upgrade to the new analyzer and give them a little bit better certainty in terms of what the measurement is and overall communication capabilities as well. So, thank you. We appreciate your time. We appreciate you coming and listening to us discuss the Monitek and the relaunch of the Monitek and the applications that we have available and really what the differentiators for this analyzer and the entire system are. We really look forward to working with you on some of the upcoming applications that you have. I think the most important thing here is understanding where we have a fit, where our value is, and what we can talk to our customers about to really help them with these applications. I'd also like to thank Steve for his portion of the presentation and giving you guys some insight. I'd like to thank Parissa for being involved, and I'd like to thank Eric for putting this all together and sending out the invites and making sure that this went off successfully. Before we close off the presentation, I do want to open this up to questions at this point in time. Does anybody have any questions?
Yeah, Ian, we have one that I'll read out for Steve and he can answer it.
Okay.
All right, so we have a question from Rocky. For clarity regarding the color measurement, are there two sources, one for the measurement and one for the reference, that are mounted inside the controller and transmitted via fiber cables?
No. So, Rocky, the way that it works, the color is the lamp source is, we'll call it open bandpass, right? It will be anything from very weak 380 nanometers up to about 1400, 1500, somewhere in that neighborhood. And what we do on the other side of the detector to reference it is we put an infrared detector, because the majority of that lamp is in the infrared, and we just choose 850 nanometers, typical. And if it's a color sensor that we want to detect yellow type colors, we will put a 450 to about a 460 nanometer filter in there. And so what we do is the detector has a beam splitter. So the lamp in a forward fashion goes, so think of a flashlight on one side of a glass and a detector on the other, which has a 90 degrees beam splitter. And we first shine through a reflective mirror that actually allows for 50% transmission and 50% reflection. So we reflect the beam at 90 degrees where we measure at 450, and we're able to get 50% of that energy through the mirror at the reference. So that's how we do the dual channel. There's no fiber optics. The sensor contains the hardware, and the transmitter is simply the electrical signals. So does that make sense?
We'll hope so.
Any other questions at this point? Excellent. Well, there is actually, I'm going to actually allow Eric just quickly, if you can just kind of quickly scroll towards the end, and there's going to be a whole bunch of key applications. We're not going to discuss those at this point in time. However, what we are going to do is we're going to be sending everybody who is involved in the presentation or the webinar today, we will be sending you a copy of the presentation so you can take a look through it. What I would suggest is if you have questions and you have applications, please get in contact with your local regional sales manager, whether that's Michael Milam or Michael Barnett or Selwyn, and make sure that you discuss those opportunities with them. Or don't hesitate to contact Steve or myself directly if you do have those questions. Again, thank you very much for your time. We really appreciate you guys spending the morning with us or this hour, and good luck selling and good luck going after these applications. And we look forward to working with everybody well into the future on some success stories in the Monitek line specifically. So again, thank you. Have a great day, and we'll look forward to working with you in the near future.